Higher mass wave theory, combining two waves. If we had two sine or cosine waves described by two different graphs, what happens if they came together? This could happen, for example, if we had two different electric power stations putting out powers of electricity, or perhaps two speakers in a room or in a concert hall. What happens to the wave pattern going throughout that? Well, let's have a look at y equals 3 sine x and y equals 4 cos x. Well, the graph of 3 sine x, an amplitude middle to top of 3, so it would look like this, and of course, being a sine graph, would cross the y-axis at the origin. The period of the graph, it's 1x, so of course that's 360 degrees before everything starts over again. Likewise, the cosine graph starts at its maximum value here, so this would be 4, going down to negative 4. The amplitude is 4, and again, one curve within 360 degrees. So the period of the graph marked here, when everything starts over again, 360 degrees. What if these two were added together? Well, you might expect the graph to do something like this and say, well, two different power sources or two different sets of sound, well, it's just going to be all over the place. It's just going to be something like that. But that's not the case. Actually, what happens is we obtain a smooth curve that comes something like this. So it's still a sine or cosine graph, but there is a new amplitude, right? It's a new height, and that's quite crucial, as I say, for things like electricity, all right, to find out what that new one would be. So we have to work out what that might be, and also it's not crossing the y-axis at the origin or at the maximum value, it's been moved sideways. So everything's being shifted to the right by, and then we often use the symbol alpha as the degrees there. Okay. So, how do we combine the two together? Well, here's how it works. Let's say, for example, that we're trying to combine, as I said before, y equals 4 cos x plus 3 sine x. Now, in the higher exam, it will normally tell you the form that they want it in. So, in this example, in the form y equals k cos x minus alpha degrees, we need to find the new amplitude and how much the graph has been moved to one side. Step 1. We'll start with the form that they want. And then we're going to use the formula sheet, or hopefully by now you'll know them by heart. We're going to replace the cos x minus alpha. So now y equals, and we know from the formula sheet or by heart that cos x minus alpha degrees is cos x cos alpha plus, because it was a minus here, that's what the rule says, sine x sine alpha degrees. The whole thing is being multiplied by the k, so I'm going to bracket it because the k is multiplying all of this and so is therefore multiplying both terms here. In other words, if I break these brackets, k cos x cos alpha plus k, don't forget the k in the second term, sine x sine alpha degrees. That's step 1, and that's already scoring marks. Next, let's compare what we have here with what we have in the question. Here, what's multiplying the cos x? The k, but also the cos alpha. They're both multiplying the cos x. So I have my k cos alpha degrees. And in the question, what was multiplying the cos x degrees? The 4. So my k cos alpha corresponds to the 4. Similarly, on the second term, my k sine alpha, which is multiplying the sine x degrees, must equal the 3. Now the next bit I'm going to show you is the theory, all right? can I say, do not panic if partway through you think, I will never remember all that. You don't need to produce this in an exam, but I want to show you where it came from. All right, but then in a couple of minutes' time, I'll show you what the bit that you actually have to remember is. If I want to now say I'm going to square the first term and the second term and add my two answers together. In other words, I'm going to say that's k cos alpha all squared. I'm going to add in k sine alpha all squared. That must be the same thing as saying 4 squared plus 3 squared, because I know that that's the values of k cos alpha and k sine alpha. If I remove the brackets here, k cos alpha times k cos alpha, that's k squared, and in cos alpha times cos alpha, we write cos squared alpha, of course. Likewise, k squared sine alpha times sine alpha, sine squared alpha. And by now you've probably looked and said that on the right-hand side it's easy, 16 and 9 is 25. Take out the common factor of k squared, and I have cos squared plus sine squared of an angle. But we learned in 4th year, or in Nat 5, that there are two equations that we had to know for that exam, one being sine squared plus cos squared for a given angle is always equal to 1. In other words, k squared times 1, so k squared is 25, so k must be 5. And k is an amplitude, it's a positive value. Now, if at this point here, as I say, there's a slight panic going on and you think, I don't want to remember all that, you don't need to. Right? All we need to produce in the exam is this. I start with the format that the question said. I substitute in the formula and get my coefficients for cos x and sine x, and I write those down, k cos alpha and my k sine alpha. And then I just, in a form, if you like, it's like Pythagoras. Just remember it as Pythagoras. It does in fact relate to Pythagoras, but it's not actually Pythagoras as it is. But if you write this down, this gains you full marks. K squared is just this number squared and this number squared, so k is the square root of 25. And now we're nearly there. We've got 3 of the marks required in the exam on a question like this. I've still to work out how much the graph moves sideways. So here's what we do next. There was a second formula we had to learn when doing Nat 5, and that one comes from this. K sine alpha, I'm going to put my sine term over my cos term. Don't forget the k at this point. So it's k sine alpha, because I can't say that sine alpha equals 3, because that's not true. Sine cannot be more than 1. So k sine alpha over k cos alpha, sine term over cosine term, 3 over 4. But as I said, we've learnt previously, sine over cos is equal to tan. And the k terms cancel. I know k is not 0. It's the new amplitude. So I cancel the k's. I end up with sine over cos. So I can now write tan alpha equals 3 over 4. And say, well, that's nice and straightforward. I can work out what tan alpha is. Just reach for my trusty calculator. Detan it, inverse tan of 3 over 4, and I get 36.9 degrees. At this point, right, we've done all the basics, but there's sometimes an extra bit to fill out. We know when we're solving a trig equation with tan that there's a second possible answer, because the question said give the answers between 0 and 360. And for tan, alpha could also be 180 plus my 36.9. So it could also be 216.9 or 217. 3 significant figures is fine. How to know which one? Well, let's have a little look at the cast diagram. We know that all angles between 0 and 90, sine, cos, and tan is positive. We know from 90 down to 180, sine values are positive. As I keep working around, tan is positive between 180 and 270, and finally cosine between 270 and 360 degrees. We've said we've got two possible answers, 36.9, which would be somewhere in here, and also 216.9, which coming all the way around past 180, that would be down here. How do I know which of the two answers? I go back to the original terms here, when I took out the coefficients of the cos x and sine x. This says that my cosine term is positive, plus 4 here. Where is cosine positive? Here and here. My sine term is also positive. On my diagram, where is sine positive? Here and here. Which of my two possible answers, my 36.9 or my 216.9, has got the two ticks? This one, the first one. So this says 36.9 is the answer I'm going to select, not the 216.9. So in conclusion, the question said express in the form, so I will do that. Y equals 5 cos x minus, and we said it was the 36.9 degrees. And that's it done. Now you may find that a bit tricky, so I'm going to show you a second example, and also to show that, of course, the question might not be in the form k cos x minus alpha. What if it's a different one? It could be cos x plus alpha, or sine x minus alpha, or x plus alpha. So, here's the second question. I'll go through the same steps again and show exactly what's required for the exam board. Step 1. Start off in our answer with the form that they want. Step 2. Substitute in using the rules from the formula sheet. Sine x cos alpha minus cos x sine alpha. And make sure that I have k on both terms. I'm often asked, could we jump straight from this first line to this third line and miss out the middle one? The answer is yes, you can, as regards the exam board. But don't forget to put k on both terms. That's quite crucial. Next step, let's match up coefficients. On here, the k cos alpha is multiplying the sine x. So I'll say k cos alpha. And in my question, what's multiplying the sine x? The negative 3. Remember, sines belong to the number coming afterwards. The coefficient of sine x up here is negative 3. So k cos alpha is negative 3. What's happening on here with my cos x? It's being multiplied by negative k sine alpha. And that matches 8. That's my two coefficients of cos x. Now on here, I don't want the minus sign here. It's going to make the next bit not true. So I'm just going to get rid of this minus sign by saying, well, this is equivalent of saying k sine alpha must equal minus 8. If you like, I'm dividing both sides by minus 1, or multiplying by minus 1. So I don't need this anymore. Next, work out k, equivalent of Pythagoras. negative 3 squared, which of course will give me a positive answer. Likewise, negative 8 squared. K squared is 9 plus 64, 73. So I'm just going to say K is root 73. I'm not going to make it a decimal, which is just rounded off. Root 73 is more precise. Finally, work out what alpha is, how much is the angle moved to one side. I'll do the sine term divided by the cosine term. So K sine alpha over K cos alpha. I'll include the signs. Negative 3 over negative 8. Now, in my two examples, one was two positives and two negatives. You can, of course, have one of each, but everything just works in the same way. K's cancel. Sine over cos is tan. 3 over 8. Since minus signs cancel. Reach for my trusty calculator. Alpha could be 69.4 degrees. Or, again, second possible answer between 0 and 360. I'll add to 180. (249.4 degrees). Or again, if you want to round off to three significant figures and call it 249, that's fine. Go with my cast diagram. I have an answer, again in this quadrant, 69.4. And an answer down here at 249.4. How do I know which of the two answers it is? Go to the original ones. My K cos alpha term was negative. Where is cosine negative on this diagram? It's plus here and plus here, so negative in the sine section and in the tan section. Where is my K sine alpha term negative? Again, in the tan section and in the cos section. Which of my two answers, my 69.4 or my 249.4, has got two ticks on it? This one, right? It will never be an answer with one tick. My two answers of my tan calculation here will either have no ticks or two ticks. If I ever end up with one tick, go back and check. There's an error somewhere. So what do I have? Second answer, my 249.4. Therefore, I can say y equals K was root 73. The question said write it in the sine term. Then x minus, and we said the second answer, 249. And the whole thing was done in degrees.